Hello everyone, my name is Daksh Sharma, a student of Electrical Engineering, BTKT Dwarahar. So today we are here to discuss on the topic equivalent circuit of induction motor. So basically we have to understand that the equivalent circuit of induction motor is similar to the transformer equivalent circuit because the energy is transferred from stator to rotor is essentially as a transformer operation from primary to the secondary winding. An equivalent circuit enables the performance characteristics of the induction motor. So, this is the equivalent circuit of the induction motor. So, here this is the R1 and X1, the stator side resistance and the reactance, and EMF induced at this point is E1. At this point is EMF induced at this point is E1. Supply voltage of the stator is V1. Current flowing here is IW and I nu, which corresponds to the no load resistance R0 and reactance X0 of the machine. And now, if we extend this from this point, if we extend this, then we can consider here the transformer winding or the induction motor itself, the stator and the rotor. The edge portion of in this is the air gap, and the inner portion is rotor, and the outer portion is the stator. Now on the rotor side, we have in running condition R2 and SX2 in this equivalent circuit. Here the EMF induced ER. ER is the rotor induced EMF, and the current flowing in the rotor side is I2 and current flowing in the stator side is I1. Now we have considered equivalent circuit of the rotor only, and we write the equation of the rotor current I2, this I2. We can write equation of I2 as ER upon ZR. Now ER can be written as SE2, which is slip times the maximum EMF induced in this condition, that is E2, and ZR can be written as under root R2 square plus SX2 whole square. Now, if we simplify the equation or divide the equation, we can send this S to denominator, which turns the equation into E2 divided by under root R2 upon S square plus X2 square. So for this equation, if I draw a circuit, it's like this is R2 and this is variable reactance, which is SX2, and this is variable supply because this slip is so this is variable reactance SE2 equals to ER. Okay, and for this equation the circuit is like constant reactance X2 and variable resistance, which is R2 by S. And constant EMF, which is E2. Now we modify the equation of this circuit is like R2 by S equals to R2 plus R2 by S minus R2. So R2 plus R2 1 by S minus 1. So this becomes R2 plus RL. So for this equation, the circuit is like R2 constant resistance constant reactance and variable load resistance. This is supply EMF induced into this is RL, which value of RL is R2 1 by S minus 1. By the equivalent of induction motor, and we can draw the circuit as stator parameter. So circuit draw is can be like this. This is R1. This is X1. Current flowing here is I1. This is R1. This is X1. This is R naught, X naught. And supply here is V1. Now in E2 equals to E1. This is R2. This is X2. This is load resistance. This is X2. This is R2. And current flowing here is I2. So now, so this RL, which is load resistance, variable load resistance, representing load resistance as electrical equivalent of mechanical load. Electrical equivalent of mechanical load. In other words, mechanical load in induction motor can be represented by non-inductive resistance of the value RL, which is R2 1 upon S minus 1. So this is all about the equivalent circuit of induction motor. Thank you everyone.